What's going on, everybody? Happy Sunday. STL Sunday. Not an often occurrence, but felt like it was time to do another one. I've been working on projects and doing a lot of work with it. So I figured we'd go over some of that stuff that I've been doing recently. Check in, make sure audio's good. My plan is to not change off of this screen because that's when I screw things up. When I go to the other one and So anyway, STL Sunday, 3D printing Sunday, whatever you want to call this. Today, I want to go over some of the tube chassis, tube project design stuff that I've been doing with the 3D printed fixtures. Just to kind of show you a little bit of what I've been doing there. And possibly we'll get into using scan data, but you don't have to I know not very many people have a 3D scanner or necessarily even care to have one, but you can also use that same principle and things that I use if you just have STLs you've downloaded from places, because it's sometimes hard to work with STLs. You don't have the same type of control in Fusion that you do with a normal solid. So if we have time, we'll get to that. If not, we didn't. But anyway, here in front of you, Fusion 360 is what I've got. If you've never used a CAD software, this one is free to hobbyists. You just have to renew your subscription, and every year is what you do. It doesn't cost you anything. You just have to go through some hoops. It's kind of a pain. I pay for Fusion 360 because I use it with my CNC router, and that affords me some other options. So anyway, this isn't gonna be wild step by step, key by key. It's gonna be a little bit more of conceptual and whatnot, but you'll get the point. I'm gonna kind of go through some of the steps that I do, starting here with some tube stuff. This is gonna be all not to a particular size or scale. I'm just gonna kind of go through and show you how I do these things in case you're interested in doing something similar. So anyway, we've got a new document here in front of us. Now, I am using a mouse and keyboard. So I'm going to turn on the origin, which will give me my 3 planes here. To pan and zoom around more easily, you can use the center click on your mouse to move around one way. And if you hold shift, that allows you to, kind of rotate around. I think it's rotate is the term for it. So you'll see me moving around like that a lot. A lot of people just don't know that little step, and it helps you navigate around what you're looking at a lot easier. So we're gonna start with a sketch. We're gonna put a sketch here on the right plane. Sketches are just like a piece of paper in space. Everything is based off of a sketch. You have to start somewhere. So we're gonna start by clicking sketch up here on the top, and then we're going to select the right plane. So that'll put us flat to that plane. And if I'm doing a tube chassis, I usually start on that plane like that. And oh my, it's acting kind of funny while streaming, but it's okay. We'll go. I'm just going to kind of do the general A to C or A to B pillar setup that I would do on a tube chassis. So, up, back, straight back, and then down. And this is actually kind of where I would leave that. I wouldn't do the radiuses and all that in this radii. I am going to do a line connecting the bottom, and I'm going to do a construction line. So rather than coming up here and clicking the line, I hit L on my keyboard. It's a quick little shortcut. I recommend you learn and use shortcuts. So go there, connect that. It's not necessarily needed, but I'm also then going to reselect that bottom line and hit X, which changes it to a construction line. You can also come over here and click this button in the top that says construction. So I'm also going to put a constraint on that bottom one to make it perfectly horizontal. That you toggle that right up there. So anyway, that is very simple. Let's throw a couple dimensions on here. Let's make this 100 millimeters tall, which I was already super close to. 100 millimeters right at 4 inches. Maybe let's go 125, 5 inches tall. It'll rescale everything because it's the first dimension that we had. We can throw a couple of other things on here if we wanted to throw a 135. Let's go 120. No, I don't like that either. Back to 125. Yeah. And then we'll just throw 55 at that guy. These dimensions aren't critical. I like to have a fully dimensioned sketch. That's where all the lines are black. I don't like leaving things that are hanging, because that gives you the opportunity to screw things up a lot easier. So we're gonna hit finish sketch. Now, this doesn't look much like a tube chassis, I know, but this is how I start things. That's a normal sketch. From here, we get into what's considered a 3D sketch. And this, you can do it multiple ways. This is just the way that I like to do it, and I think it's easiest for me. So I did a new sketch, and then I just selected the front plane. It doesn't really matter what plane you select, though. And one little tip for this. While the sketch tools are the same in all of these menus across the top, if you go to the surface menu up here and then go back to sketch, how things act is a little bit different, and that is helpful for what I'm about to do, because we're going to be drawing along all different points here. So over here on this right dialog, right behind my giant head, there's a little box that says 3D sketch. So click that on. With that on, Ben, what additional CAM functionality comes with the paid version? It's things like rapids, just allowing the rapids to work, so you're not just traversing at feed speeds all the time, which is super annoying. So it's something I recommend. Okay, so we clicked on 3D sketch. We selected line, and we're in the the surface and then sketch menu. So from here, I'll come and I'll go to the first point, which is right down there on the origin, and you'll kind of come out and you see how it'll follow that red axis. So we'll follow that, and let's just do 75 millimeters out that way. Come up, do a line again, select on that point, and we'll do 75 again. Line, we're going to come to this top one. Here we're only going to come out 60. Go back, 60 again. We're going to do a line somewhere along this edge, and we're going to come out 75, and down to the bottom, 75 again. Whoa, make sure that we snap. So you can see that we're going to hit that horizontal vertical constraint button, and we're going to select all of those lines that we just made, and that will make all of them except this one here fully constrained. Now that's not constrained because we don't have a position on it height wise. Like you can grab it and you actually can't just grab it and move it, but it's just because of little things. So we're gonna grab a dimension here, and we're gonna say this was 55 in the first one, so we'll just match that to make things simple. And now that that is fully constrained, you'll see these things, which may not make a lot of sense. But we're going to go and we're going to select each of those lines, and we're going to hit X to toggle them to construction. I just like to do this. It's not super necessary, but I suggest it. Now I'm going to go back to our line command, and I'm going to connect all of those new dots. I screwed up, so I hit escape. So now we have basically what looks like the exact same sketch from the side, but when you rotate to the front, you can see now that you've got that tip in that you would normally have on a cage. So like I said, I didn't do the radius work on the previous ones because it would make doing what we just did here much more difficult. But now we can come in and click that fillet command, and I can add what I normally like to do is about a 15 millimeter radius. That works pretty close for my bender, so that's what I like to do. So we're going to do that to there. And I'm not going to do it back here. I don't typically like to have a radius joint right here. On I guess if it's a cab only truck, you could, so since that's all we've drawn. So actually, no, I'm going to leave it this way specifically for a reason. So now we've got what would become one tube, and then we'll have another here. So we need to add a radius here. 15. So these will become two separate tubes. I'm going to hit finish sketch. So now we've got these sketches here. We can come up into the create menu, go down to pipe, and then we can select our path, which I'm gonna turn off chain selection. I'm gonna select the bottom, this one, that one, and that one, and we're gonna leave it right there. We want to draw just like we want to fabricate. So 10 millimeter is much too large. We're going to type in 3/16 inch. I didn't want to do that. Need a space between the dimension and 0.1875 inch, and it should be fine with it. Yeah. Sometimes it doesn't like when you combine math and unit changes, but it's no big deal. So we hit OK with that one. We're going to repeat that one time. Oh, you can see that our line disappeared. So if on the left side here, you expand the sketches, these are what we're looking for. We want to turn on sketch 2 again. So now you grab these, and you can see it's red, and that's because this is intersecting that one there, which is fine. We just change this to new body. You don't want to join it either. You want it to be a new body. It's important. It's important for metal fabrication. If you were 3D printing, it wouldn't be the way you would want to do. Could you use a sweep here too? You could use a sweep. However, if you did a sweep, you would have to draw another profile at the bottom to start on. So basically, this just saves you a step. It makes things a little bit easier in general. It's really the only way that I do tube work is with this command. So even if I was fabricating this with tube instead of solid, I would do all these steps the same. You can make this a tube if you wanted, for if you wanted to do like weight calcs and things like that, but in most situations, I don't feel like it's worth the extra work. So we have a tube chassis set up, kind of, right? We're going to kind of complete this a little bit to make it slightly more complete for you. Let's see. Let's just do we'll do like a door intrusion bar style, and then we'll do a couple of crossbars, get everything mirrored so that it looks appropriate, and then I can just jump right into showing you the fixture side. So that's what we'll do next. Let's we're gonna do a new sketch. I'm gonna jump into surface, and we still have to just select a plane. We can do this outside plane here, which it's, sorry, that's not the outside plane at all. We'll just select the right plane. That's fine. Actually, I'm not even really sure which one it selected for me, but it also doesn't matter. So when you're in, like I said, when you go to surface and then sketch, things just act different. It's a little thing. It's really nice though. So I highly suggest it. And now we can kind of just come in here and you see how it selects. When you zoom in, you see how you can see that center point of that circle. There's a few ways you can like make this easier on yourself, but if you turn off the bodies, then you can come in and you can select anywhere along that previous path, which is what we were working with. So if we select right at the center point of the radius, we follow that blue, let's just go out to whatever point we want, and then say, let's not go to the center point of the radius, let's go to let's do a little kick up, something like that. Now, this here, let's dimension that just for, I hit the letter A, but you can see how this one here, if you look at it from the front, it'll actually tip in with it. It goes in and then it kind of goes along with that tube just because of how that top one goes. It's not a huge deal, but it would be a lot harder to draw if you didn't just do a 3D sketch. So let's put 130 on that. That'll define everything. We need to put a radius on. 15 again. Finish that sketch. We could do crossbars and everything in this one if we wanted. Sure, say you want to go back to it. Let's hit edit, edit sketch, and let's just let's drop a top one in there. Let's do an arced one because why not? So we're gonna go from there to there. This can be a little bit funny, but I'm clicking on that line. Now that won't give me the shape that I want, but it'll put the line in the plane that I want. So I'm cheating a little bit. You see how it goes out and then in? Not what I want, but it got me that line on that flat top plane. So we're gonna do a tangent constraint on that, and that'll get it just how we want. We can throw a, I don't know, I was gonna say, I don't know why it's blue because it should be fully constrained, but it's fine. We're gonna hit finish now. One of the times I'm breaking that fully constrained normal rule that I go. So we've got this one, we've got that top. We can do a straight back here since that was, we'll go back and edit that sketch one more time. And actually we can just take this one and, oh, actually, no, we can't. Well, we could. We can hit P for project, select that line, hit OK. Oh, no, actually I can't because I'm not on that work plane. It probably projected downward and I just didn't notice already. Oh, it actually projected way out here. We're going to delete that line out. So now we've got three more tubes to do. We can turn bodies back on. Go to pipe, select that one, new body, everything else stays as it was, and repeat that process. Oh, we gotta turn our sketch back on since our lines disappeared. New body. One more time. We can turn chain selection on here and then it will grab that whole line section. New body. John Roberts, 160. Thank you, sir. Love STL Sunday. Really helped with my hobby projects and with work. Thank you. Thank you, John. And also, before the stream, I saw that there was a couple of other super chats, and one was Captain Insano, shows no mercy. Thank you, Brandon. Much appreciated. Here's 20 so you can continue doing this horrible, low-down, no good for nothing show. Clinton Lloyd, glad to see you're doing this again. Thank you. And RC Underdog, thank you, Paul. Hello, Josh. Tomorrow's my birthday. Can't remember how old I'll be. I'll take the return of this show as a present. Much appreciated, everybody. I do enjoy this show, even when it's not our most popular one, but it's okay. Hopefully you guys learned something. Maybe that's why you're here. Maybe you're just bored. So we now have basically the tubes that I think we need for what we're going to show. We could do, of course, the lower seatbelt bar in the back, our windshield bottom bar. There's all kinds of detail that we could throw in, but I want to get into showing you the fixturing and things like that, rather than just going through and adding a bunch of other steps for things that you may not actually need. So we're going to do a mirror, and we're going to select the bodies that we want to mirror, which is pretty much all of them. Oop, we forgot a guy. That one. Select the mirror plane, that side. We're not going to hit join. We're just going to hit new body. Otherwise, it will make everything connect, and we don't want to do that. So now we can hit combine, and we'll combine the ones that we want ourselves. So that, there you go. Now you have something that kind of looks like a cage. One reason that I like drawing cages is so that I can always, modify and change. Say there's something about this that in the end you just didn't like the style of. Well, you can go back to that very first sketch and say that I want this to be 135. I want it to be laid down way more. And then when you hit finish sketch, it is now redone that, and it's laid it way back, and you can see, like, you know what, I like that style way better than where we were before. So we're gonna leave that. It's just, you always have that ability. So you need, and then if that wasn't the one, maybe you wanted more pinch at the top. That was in sketch number 2. You could go back to that and edit it, and 55. Maybe you just want the front bar to tip in more, and the back needs to have that odd, it needs to flare out. Whatever it is, you can just keep going back and tweaking your cage design over and over and over. That one visually I do not like, so I'm changing. Otherwise, I'll be perturbed. Okay. Hopefully nobody has any questions. The tube stuff here, I've gone over this part of it before, but as a refresher, it shows you what's going on. Now we do have overlapping tubes and joints, things like that. That's okay. It's how I would generally prefer to have it at this stage. I leave it like that even for my fabrication templates, and that just gives me the ability to kind of tweak as we go. So this is a super, I feel like the stuff that I'm about to show you with fixturing, making fixturing 3D printed so that you can fabricate, may not be for everybody. Not everybody is into 3D printing. Not everybody is into fabricating, welding, brazing, whatever it may be. So we're still going to go through it, whether some of you would like it. Hopefully it helps somebody, and I can show you, how I've been doing things. First of all, things that I've been doing lately that have really helped me are the 3D printed bend templates. Not the whole fixture even, just the template of the actual tube, so that I can, paper templates are great. They helped me build things more accurate, and I really enjoyed them. But 3D printed templates make me 5 times more accurate than paper templates did. There's just certain things about projecting, taking a tube and putting it on a piece of paper, and you're kind of like, that seems about right. It's projected about. That's different than when you're putting it into this fixture that maybe even has complex bends, and you're like, that's perfect. That fits just right. So let me tell you, if you want to get into this stuff, this will make your work so much more precise, so much better. I can't say it enough. There's ones that are way easier than others. So this tube here has a bend in it. This tube here has a bend in it. Those are both single plane bends. Even if this had 2 bends in it that were in that same lot, like if you looked at it straight on, like we look at this back one, that looks straight. It could have 5 bends in it going every which way, but as long as it was in that one, if you looked at it from the side and it was flat, it's a single plane. That's the easiest way to do things, and the easiest way to make templates. So let's do that one first. I'm gonna select all of these bodies just for the sake. I think I've got them all selected. I'm gonna hit the V button on the keyboard, and that'll turn them off. We can select that. Oh, it doesn't work with sketches. Okay, that's fine. So we've got just the single sketch on. We can even turn off this body for now. we need to create a plane here. Again, a plane is like where you're setting the piece of paper for your sketch. It has to know where you are. So sometimes you need to make up those planes because they don't exist. When you start, you only have 3 planes. You just have right, top, and front. But we need one over here. So we're going to go over to construct. We're going to hit that drop down, and then I'm going to use this plane through 3 points or plane through 2 edges. You can use either one. They're both very easy. Say 2 edges in this one. We're just going to select this edge and this edge. Then it's going to create a plane for us. Now we can hit sketch and select that plane, and it'll rotate it to it. From here, I'm just going to hit, well, first I need to hit P for project, and I'm going to select all 3 lines of that tube, making sure not to grab the line over there, which is actually our front tube. So we just have that. So I'm going to project those, which means that those are now in my sketch. I can use them. So I hit enter, and those are purple. Now I'm going to hit offset, this one up here, and we're going to select all 3 of those again. And I prefer to go to the inside of my bend. And this dimension isn't critical. I like between 8 and 10 millimeters. We're going to hit -8, so it goes to the inside. And then from there, we're just going to connect the dots at the end to create a closed profile. And now we've got the template that we're going to use basically to create everything. So I'm going to hit E for extrude. We're going to select that. And on the right side here, we're going to hit symmetric. So that means it's going to go each way equally. We're going to hit this toggle option there, which just means that we type in 1 dimension for a total distance. And then a 3/16 tube is just under 5 millimeters, 4.5. So I like to go to 8 for a total width. New body, hit OK. So now it's just hanging out there. When we go back to bodies and we turn, let's just turn everything on. Everything can kind of blend in here. I'm going to hit A for the appearance menu. That'll pop up. I'm going to right click and duplicate, and then right click again and hit edit. And we're just going to select a red color. And then I can drag that onto that body. So you can see what we've created a little bit more. If that makes sense. Now, we're going to go back up to that combine. We're going to select that. And then we're actually going to use the subtract function. So select subtract. The target body is the thing that we just created. And the tool body is the tube. Now, we need to click this keep tools so that it doesn't delete our tube that we started with. Then we're going to hit OK. And that's it. Now we've got a perfect bend template. If I go over here, right click and hit isolate, it'll turn everything else off except that. And you can see now we have this perfect representation of what our tube should follow. And then you just export this piece. You come over here and hit, before we do that, we're going to do one other thing. We're going to come in here and I'm going to hit the press pull. I'm going to do that and I'm going to select where the tube goes. Now in here, I'm going to do -0.2. And you can see how that increased that radius a little bit. When we turn I'm going to hit right click, unisolate. Hold on a second. What tube? I'm going to label this one B pillar driver. And that's our B pillar template. So we're going to re-isolate, and I'm going to turn that guy back on. You can see, can't see anything when I zoom out that far. You can see it just gives us that little bit of tolerance around there. Everything's going to be a little off. Your printer's not going to be perfect. Your tubing isn't going to be the perfect fit to the template. If you give yourself just a little bit of fudge room, then you end up with something that's a little bit easier. It's one little step. It's worth taking. You could modify that 0.2 to any any dimension that you want. But that's my recommendation, just to give you something to, little fudge factor. 0.15, 0.2, both of those have worked well for me. Now, not only has this given us the bend template, so you're gonna be able to bend your tube and set it there and make sure that it's the proper, bend radius, also the bend position. Do not cut your tubes before this. Bend it first, leave extra on each end, and then this thing is also your length template because we made it the proper length. So mark your tube after this point at the bottom and at the top, and then cut it to that length. And as long as your cage is accurate with everything else you've done, you end up with a tube that now that is supposed to be about this long. You're going to have to do a little bit of coping and stuff at the ends. No big deal. Because now, if this amount of distance up here is not what you want to do, like if you wanted to go to a 45-degree cope, which is like what I did on this truck here in front of me, then before you would get to this point, you would just extend this by 3/32 of an inch, or not. You could just leave it like that and fill it with braze or weld or whatever you plan to do. Little differences. Those are going to be personal preferences on your end, how you like to fabricate. But that's the reason why I don't go in and cope the joints in CAD, because this just gives me a nice, easy way to calculate fab, and then I can go in there and cope my joints in the garage, and everything works out really well. This, though, is a length and a bend template, not one of like the fabrication jigs. So that is a different process. But this is how I do these, and I'll do these for each tube that has a bend. And I even did it for the straight ones on this truck here. This right here, the one if you can see, that says rear bumper. This was just a straight template, and I used it just so that I knew the length that it was supposed to be, and then I just labeled what tube it was supposed to be right in the software. So it was, if you're doing a ton of different templates, it's nice to label. Labeling's pretty easy if you wanted to. Sketch, select your template, and then you can come up here to text. Just go, this is going to be, I think you could have rotated, but click text on path. Yeah, I could have done it that way before. And then this would have been B pillar. We'll make this 6 millimeter, 5 millimeters. I like to use impact. It's easy to print and it looks good. Lowercase looks like crap, but whatever. So then once we've done that, finish sketch, select it, hit E, and I'd go -0.2. Gives you just a full layer height of 3D printing, which is usually enough. Labeling's nice. It's easy to forget, especially if you're doing straight little templates, because, it's like, which one was this? So it's worth doing. The bends, usually you can determine which is which, if that makes sense to you. Now, the fabrication jig side, showing that part of it. This process is pretty straightforward for the rest of them. It does get this A pillar. That's a little bit more tricky because it's multiple, but you could just do basically the same process in a couple of steps. Do one plane for the top portion, one plane for the bottom portion, then you can join the pieces when you're done. That should work just fine for most people. There's different ways to do it. It's up to you on how you would like, but that should give you an idea of the principle of the project. So I'm going to turn that one off. So we don't need it. I talked a little bit about creating new planes before, and that's basically what you'll be doing over and over to create the jigs for fixturing. So we're going to turn off most of these bodies. And we're going to turn on those two sketches. From here, we're going to hit new, well, not new sketch, not yet. We're going to come up here to construct, and we're going to do plane at angle. Yeah, plane at angle is going to be our first one. So we'll select that top tube there. Now you could do this flat. Works fine. Excuse me. But it can make it a little bit harder to get the tubes in and out of the jigs once everything's welded in place. So what I would suggest doing is rotating this plane to an angle. You can go either straight in, but I also don't recommend that because once you weld the two halves together, then you kind of end up with the same thing. So 45 works pretty well. And from here now, you can just do a sketch on that plane. And we'll just do a box. We're going to dimension 4 millimeters off that way, 8 millimeters total. And we want to stay a little ways away from the intersections because of the heat that will creep from the tubes as you're welding. And if you're planning to braze, you can still use all of this to fit things up and make sure everything fits perfectly and then take it away to do that. Or try and get some heat blocking putty. There's things you could try, but I think this mainly works best for TIG welding. And I agree that now you need to know CAD, you need to have a 3D printer, you gotta have a TIG welder. All of this is why this show is so wildly unpopular. I know why this show does not do well. I just alienate everybody slowly or quickly even. But thanks for being here for it. We're going 25 millimeters away. That leaves a short section, but that's all you need because you're going to have had a template to make sure that it was the right bend shape. So we're just going to make a few of these along the way, and that'll give you the places to put it. So we've created that. We're going to hit E for extrude. Drop that guy down, say 20 millimeters for now. It doesn't really matter at this point, but we need to repeat that a bunch. So I'm going to do that. If you guys have questions, put them in the chat now because I've got some time. So I'll try and answer questions why I just repeat that exact same process I just went through a number of times. Or if you don't, and all of this seems pointless anyway, feel free to tell me. 8 there, 4 there. After we get through this part of it, we've got to connect all of these random little escape, undo. We may have to go to 20. Otherwise, we're just not going to end up with enough. So there. This will all make sense. Don't worry, your pretty little heads. 45. Nope, that's 45, the wrong direction. So we're going to hit edit, feature. And rather than 45, we're going to hit negative 45. What in the world did I do there? There we go. I don't know. Maybe that's what I did before. Just look wrong. Until I think so. I'm gonna go to 20 on those. That. Oh, we need to set our 4. Something like that. Any chance you could go over importing a 3D scan? Yeah, I think that this is probably going about quick enough that we'll probably be able to get to that. It is something I wanted to do. So before I talked about doing creating a plane through 2 edges. I also mentioned you can use 3 points. That's another one that I like. So I did 3 points there, and we'll just click this one, and this one. Now I'm gonna hit P for project. We're gonna grab those, and I'm just gonna do my offset. Same thing the opposite way. -4, and then I'll create a line out here, something like that. Is there a shortcut key for adding dimensions? D for dimension. That is the one that I use all the time. I use shortcuts a lot. I probably do it unconsciously, and I forget to tell you guys. Yeah, if you have any questions, absolutely drop them. So you can see that one was at a bit of an angle already. That's why I just kind of left it like that. And we need a couple of more, and then we'll be able to go to the next chapter. Actually, what's 45? Yep, we're gonna go 45. And 20. We'll do one more down here. How did I do this again? I forgot. So we'll just do from down here. 20. All right. So now we've got all these random stuff. Josh, how would you design your cages if you didn't have CAD? I've been designing my roll cages in CAD since, I don't know, like 12 or 15 years now. There's no better way for me to do it. CAD is the way to do it. CAD is the way that it's done in the full-size world. It's done, like, honestly, if I wasn't designing in CAD, I guess I would only be freehanding, because to me, there's not a barrier for CAD now. There used to be. There wasn't free CAD programs before. They were super hard to get. It was a nightmare. Now they're available for free. So, like, the only thing stopping you is not wanting to learn. Of course, there's like not having a computer that can run it. That's 100% a thing. computers aren't necessarily inexpensive. So there is that. That's a thing. I get it. You know, graph paper can work. It's, you know, but it's, yeah. You know, there is other options, but you know, that's the thing. You can do it old school, which is just CAD before CAD, CAD before computers, cardboard aided design. So now we need to do what we did with the other template, and we need to create the groove. So we need to make sure keep tools is on, and we got to go through this process a handful of times quickly. Make sure you're selecting the block first and then the tube. That's the order of operations for this particular tool. So we've got all of these things hanging around now. The hard part is over. That's the hard part of creating these silly jigs that I've been making. From here, we're just gonna create a new sketch. We're gonna go to the bottom. And now we just need to connect from the, you know, tore up from the floor up. We're starting on the bottom, and now we're here. All of the, what other things could I reference? So I'm gonna hit P for project. I'm gonna grab the back side of this one, back side of that one. That one is flat, so we're just gonna grab that line there. We're gonna grab that guy. We got anybody else floating around? We need that one. And we need just this line here. Do we got them all? Gotta catch them all. So that is, those are our areas we need to connect. Hit look at, and it'll rotate us up. So we got that. Now let's, I'm gonna turn off bodies for a minute, because this does not have to be fancy. We just need to, well, actually, I'm gonna undo a couple of those, and we're gonna do this slightly different. We're gonna hit finish first, okay? We're gonna turn bodies back on. Bodies back on, there we go. And we're just gonna extrude up to some of these for a moment. So we have those profiles that we've done there. We're gonna hit E for extrude, click that. Over here where it says distance, we're gonna say to object. And then we're gonna extrude that up to this object. And we're going to hit this one over here. This is like brings it up to all the edges. It can matter depending on the ones you're doing. Now, of course, it's intersecting, so it wants to cut. We're just gonna say, we could say either join or new body. I suggest you do new body still. Otherwise, you can start like connecting your tube work to your fixtures. So it's just an easier way to do it. We do need to go turn our other sketch back on because we need that. And we're just gonna repeat that same process for the rest of these to give us, well, again, you have a lot of options. At this point, you could just like extrude this guy back so it touches there. You know, same here, and you start blending stuff, but I'm not gonna do that just because of like just brain power while streaming. I'm not saying that I wouldn't or I haven't done those. I'll open up the jig file that I made for the hack here after we get through this part, just to show you like what I kind of went through on that one. Extrude to object, new body. So you can see we're starting to get all of the things aligned. This one, we can grab those two profiles. Oops, to object is what I meant. kind of a funny guy hanging up there. We're gonna be able to fix that super easily, and I'll show you how in a bit. Not a big deal. So we still have these guys floating out there. That's not a tough one to solve though, so we're gonna be in good shape. I'm gonna go back to the bottom. And now we can just kind of connect some dots, honestly. And like that. We'll just go back. We're going to project that whole thing, but we're not going to go the whole distance. We're just going to go to there. I'm going to go all the way across just because it'll give us a nice wide base. I don't know where we're at. I'll hit a horizontal constraint on that guy. There we go. Project that. We'll make that intersect. So we're still open. Where am I missing a profile? Oh, this is not projected into here probably. Same goes for here. So there, it's got it closed. So now we're just going to be able to grab all of that, grab this and this, and let's just go up like, go up 8 millimeters. 10's a little fat on a base. Turn the bodies on so it shows, and hit new body. Okay. We haven't connected that guy yet. We just had an overlap, so. That there. It's okay. This is an oversimplification, but it would still 3D print, so like it'll still work, but it's not the prettiest thing I've ever done. Again, we're gonna not hit join. But what I think that has done is that has, where was our last tube structure? It should have been that one. So you can select here through here and turn those off with the V command. So then we're only left with templates of the jig. So this is all one piece to 3D print now. So we're gonna go in, I'm gonna hit the combine. We're gonna actually use combine. I'm not gonna hit keep tools, but we just need to select all of them. So those are all the things. Hit OK. And now that's one body. I was talking about this guy hanging up there. If we just want to select that face there and hit delete, it'll cut through that. It's a handy little thing to do. Just go in and cut bodies here and there. Now this would 3D print. There's probably things I would do. I'd come in here and I'd probably add a big old fat fillet. Make that a little easier. Is this not joined? Did I miss one? That's weird. I don't know why that's not showing a consistent... Oh, because it's not joining. Well, that's just interesting. Let's turn that off for a second and just drag that down by 0.1. Now it's 1. Weird. It just was not combining. This guy here is my least favorite. How it does not combine, like connect. So I just grab the push pull and I just grab that out and just drag it a little bit. Would I not? I hate that. I don't like that at all. I'm gonna hit extrude instead, and I'll just grab that and drag it out. 7, yeah, sure. Then come down here, select that, hit delete, and it'll clean that face all the way back up top. Just made it stronger, easier 3D print. Again, you could add fillets here. You could take and grab this. It's a little thin back there, so like just add some thickness to it. 3-4 millimeters like that. That thing will be super stout. I mean, it's almost touching the other one. I'd probably just combine them, but it doesn't really matter. So now you've got, go back up, we'll turn all these on. Like, that's a jig. That is all I'm doing to be able to create tube chassis so much more accurately, so much simpler. There's a couple of other things that I do like to do, and that is add zip tie holes. Wow, oops. Yeah. 10 is there. 3 millimeter hole, it's fine. Just throw it through there. I don't use the hole command all that often, but if you don't want to draw another sketch, these are not critical. These are just so that you can put a zip tie through stuff, you know, like, oh. So like, just make it easier on yourself. Just put them where they need to be. You know, if you're doing multiple on a face, like, yeah, it might have been easier to do a sketch with 2, but probably not. So there, you know, now you got zip tie holes too. So you put your tube in place, you zip tie it in there, and then it's not moving. You can, once that's fixed in place, now you can like cope your tubes, make sure it fits, cope your tube without trying to like hold one and the other and be all awkward with it. It just makes, it's just done. It's, you know, let's see, is there any of them that would be difficult to get to here? Not really. These would all be pretty simple. So that's pretty much that's the hard part with the whole jig setup. I'm gonna open up. My Lord, 11 o'clock. So these are all the templates and jigs for that most recent project I've been doing. The yellow are my tube length jigs, and the green are the ones that are, you know, for the actual like fabrication and assembly of the entire jig. Now, let me turn off a couple of these. There we go. A couple of stragglers there for my sliders. But you can see that I did basically the same type of thing for everything else. I also did the crossbars in this. When I fabricated the side first, then I created the other side. Then I bolted, oh, why aren't these the final version in here? Did I lose my Did I lose my final version with the bolted? That would be unfortunate. Huh. I mean, I don't really need them again because I already created them and used them, but this was completed, and you know, there's overlapping joints in the middle that allow stuff to bolt together. So, oh, and the whole back half is gone. Sick. Alrighty then. Well, you get to see a portion of it. I guess I lost the data for the rest of that. I'm glad I didn't need it, but that seems so weird. Huh. I don't think I did it in the cage file, did I? We are checking. Bodies. No, it's not here. Well, that is unfortunate. Shit happens. Anyway, so the long story not so long. Let's talk a little bit about I did have a warning in that. What was it? The component is out of date. Oh, I just have some sort of referenced component in here. We'll update. See if it like miraculously brings all my stuff back. Nope. Nothing changed. Everything is not awesome. That's quite a bummer. This is me mad. Okay. Whatever. I'll get into that later. But scan data. Again, this can be about not just 3D scanning, because again, I know most people don't have 3D scanners. But also, if you've got an STL file, this can be handy because it handles it basically the same way. So we're gonna load this in. I'll show you a little bit of what I had done here. So I've kind of already chopped this up too much to really make for a good demonstration. So let's just do it this way. Let's file, save, STL Sunday demo scan. We have to save it to be able to bring in scan data. So from here, we're going to hit insert mesh. Now this could also be things like your, whatever you want to call it, STLs. You could load them in from there as well. I'm going to go to my Escalade body scan. We'll let it freak out for a moment. And here is the Escalade scan data. Now, there's some weird stuff with this one because it's been fixed by like filling in the backside. It wasn't really important. I just did it because while I was checking things out. This was, where's it at? Well, I've already cut it up. Never mind. This was an HPI Escalade body for the, what was their truck? The Savage. And I wanted to use just the center section of the hood. But if you downloaded an STL file of a body you liked, a Mercury Cougar, whatever, then, I don't know where Mercury Cougar came from. Then you could do a very similar process to this. And scan data on its own can be like almost useless to you if you don't know how to use it. And that's the big problem with any tool. The CAD software as well. Like, if you don't know how to use it, it's freaking garbage. It's just like, what am I going to do with this thing? And I've learned more and more every time I use it. So it becomes more and more handy, but it doesn't make it always. But let me just show you a couple of the, do you have to scale scanned files? No, if you have a proper scanner, it should bring it in exactly 2-dimension. And that's important because that's why I have a scanner. That's what I want it for, is so that it is accurate. But no, it should be perfect, and it is. So from here, like, I wanted to use this hood. So, but I didn't necessarily need this whole thing. So if I wanted to like trim this down into areas that I needed, like, I'll create a sketch. I'll just select that top plane. And I know that I wanted to cut it basically like that. So I'm gonna hit finish, and I just have a random line, but we're gonna do like what we did earlier, and I'm gonna plane at an angle. We're gonna select that line. I'm gonna hit 90 degrees. It goes straight up. Then in my mesh, I can do a plane cut. Select the body, select the plane. Do that. Trim, no fill. Now I have half of the hood that I want. If I want to do the same thing again, select that, and we'll just select the what would it be, the my right side. We're going to flip the side that we want. I only want half the hood. There's no point in doing the whole hood because it's the same from left to right. So just do half of it, and then you can go from there. Lastly, we'll do a sketch on the front, and we'll trim this scan about like that. Seems about right. Trim. Again, this can all apply to something you import just the same. Hello. Mesh, plane cut, this body, this plane, and we'll hit OK. Now we've got a bunch of planes that are in the way. We can turn those off. I also have a little bit more data that, like, I've got a second half of this thing down here. I can do a separate, select the body, hit OK. It'll separate those two shells out for me now. Whichever one. I don't need that guy, so we'll hit remove. And now I just have that center section of the hood that I wanted. I can turn off that previous sketch, actually both of those. I don't need either of them. Still, this is somewhat useless to you. You have to go from here on how to use it. So up here, this is the tool that's like, there's two tools you need for scan data or working with STLs to make things so much more powerful for you. So the first one is this right here, create mesh section sketch. Body is what we just did. Selection plane, for now, we're just going to use that right plane. Awkwardly enough for this demonstration, it's not showing us everything we need. Sick. We just cut it along that, but for some reason, it's not giving me everything. Whatever. It's whatever. Actually, I'm just going to take and drag that. I'm going to drag that way up here to just after the import. See if it still wants to act stupid. Okay, whatever. Put it back where it was at. So we're gonna do that one more time. Select that, and we're gonna select that plane that we created on the side and hit OK. well, now this is just being ridiculous. Let's see if it gives me my sketch where it should be. Sometimes Fusion just wants to be a pain in the ass. Just to be a pain in the ass. Okay, I'm deleting both of those. I'm going to roll this all the way back to where at the beginning we had our full... Oh, wait, I know why it wouldn't do it. Well, I know partially why. Turn that plane back on. So I'm going to create that now. That body, that plane. Yep, there we go. Okay. Now, let's try it one more time with this and... There we go. Now it's working. We've fixed it. Roll it back until it's got things fixed for us. Looking more appropriate. So from here, it's given us these lines that we can now use to determine where the scan data intersected a plane. It's still not totally usable because this isn't like a normal sketch line. It still acts dumb. You don't have any control over it. But what you do have control over is you come up here to create and you do, oops. We go back to that first one over here and we hit edit feature. Oh wait, sorry, that was the, I need the, no. It's fixing itself. Okay. So we come up to the sketches that we need. That's what it is. So you come up to this sketch, we hit right click, edit sketch. And now we come up here to the create menu and we hit fit curves to mesh section. And this is what's the most powerful part. So spline fit tolerance, that is important. You can play with it. There's not an exact number to tell you, but we're gonna come in here and I'm gonna say I need this line to start about in here and then I want it to go to about here. And now you can see it's created this blue line that goes over top. That's more of a normal one. You can see it's not super smooth though, and that has to deal with this deviation. So we're gonna say like 0.5 and see how long. Sometimes it doesn't like to do it quickly. Yeah, it likes to, we're gonna delete it. There it goes. We're gonna try it again. 0.5, first point. There. This is one of those tools that is finicky. Now you can see how it's already starting to kind of blend, like smooth those things out. It kind of depends where you want to put it. We'll put it like there. Now we'll hit OK. And now it's going to be a much smoother line throughout that whole thing. And that now is a usable line. We're waiting for it to like thinking. There it goes. So we need to do that one more time with this one over here. That's this guy, edit sketch. Create fit curves to mesh section. And we're gonna do about the same thing. We got some like crazy noise in here, which is not great. I would, you know, for a design that I was really getting picky on, I would definitely go in and like tweak on these things. So we're gonna hit OK. We got a couple of things there. I'm not sure. This may not, none of you guys may care about this. This is one of those, but I'll just show you like one more thing about this, because for what I would do from here, or what you, like the next step often would be, I would actually be in the surface menu. Not always a super common thing for people. Come in here and I would select that blue line that we created there, and then the other one, and hit OK. And now you've got basically what was half of that Escalade hood. I'm gonna hit R, which is the hotkey that I've set up to flip the tangency, or the normal. It's the normal dimension of the hood actually. Again, this doesn't apply to most people, I understand. And now if I turn the scan data back on, like it follows that hood pretty much right on. It's a little under there, things like that. But that's pretty close to that recreating that hood of that Escalade. Working with surface is a whole nother world. It's a lot of fun. It's super powerful. Like I could hit offset from here and say 2 millimeter. Go up. I would actually need to reverse that bottom one again. But I could probably do another loft between that and that. And then I would just kind of repeat that a few times. That line and that line. Loft once more between here and here. And I need to actually reverse the normal of a few of these. So you have to do that. Then you would stitch all of those surfaces together. And last thing to do would be to patch this one side. And if I reverse the normal on that so that all the normals are the right way, stitch everything. And right now over here on the left side, you see where it says body 5? Once we do this, now it has turned that into a solid. This is like a normal solid that you have worked with before. Now it went from being a surface to an actual solid. You can see in here how this is a little funky. This isn't perfectly straight. I would fix that. Like if I was for the Escalade hood that I made and I recreated, I would fix that personally. But you don't have to. If you just mirror this on that plane, it wants to not do it. Let's decent amount of work to recreate a fairly simple shape in this kind of, but this really isn't a simple shape. It's got, you know, it curves down here, up and around. Like none of these are flat surfaces. Like to recreate this any other way, it would take way more time. This is a really quick way to get this stuff done. Like this is not just some like simple flat shapes with some fillets. Like this just, it's not, if you turn on, like if you go to inspect and you go to zebra analysis, If this was flat shapes, these lines would be straight, you know? Like when you look at it, you can get areas that, see right through there is fairly straight, but they're not perfectly. So that'll give you a bit of an idea. Oh yeah, I was trying to get that mirrored, and for some reason it was not wanting to. I'm just gonna, oh, I see why it doesn't want to. It's for some reason doesn't want to say that that is a flat. We're just gonna cheat, and we're gonna go -0.1. Letting it think. So it's that guy. We're gonna do a quick oh, it didn't even want to do it there. Okay. Did that cut? Oh, it still wouldn't do it because of it didn't do it the first time. Let's see if that should get some of it. There we go. This is, again, just for demonstration, probably not the way that I would do it, but so there you go. That pretty much recreates that Escalade hood. From here, if I go to, someone had asked about the mold making process that I do to create the forged carbon stuff. If I said I wasn't going to do this, but if I switch to, this is that hood that we basically just drew. And I've already made it out of forged carbon fiber. I started that process yesterday, or the day before, whatever, and got that done. And I've got it wet sanded here, but I needed to create the molds and everything to be able to do that, to do forged. So, switching back before we start discussing, I'm going to take this and roll it to this point. This is the actual Escalade hood that I drew and made. You can see it's a little bit sharper in the cowl area. I made things a little bit more, a little bit tighter. I spent a lot more than 20 minutes on it, or 15 minutes, whatever that hood took us. So after importing the hood, the next step was I created a new plane. I did it on 3 points. So I did the back corners of it, and then the tip of the hood, just the tip. Then I did a sketch that was a projection of the hood body. That way I could extrude that up to the hood object. And this created the large solid that I would need to basically make the negative of the mold. I extruded that down a little bit to give me a little bit more area or depth on my mold itself. And then from here, I will have created a sketch around the outside. So here you can see the sketch going all the way around the outside. And then we would have extruded that big blank body over top. Both bodies are still there. I can turn off the original hood and it's just encompassed in there. So from there, I did a subtract. So now if I turn off that main hood body, you can see we've got a big old hole in that blank that is the shape and size of the hood. More sketches, and that was just to reduce some printing time by taking a wedge out of the bottom. I shouldn't have done that though. I should have left that flat so that my pressure during compression was perpendicular to the surface that I was clamping onto. I wasn't thinking when I did that. I did it too fast, and it caused me an issue during the molding, but I was able to correct it after the fact. From there, I created a sketch that went around the outside to give me my bolting flanges. Oops. So created the bolt flanges, and then I created a body that would become the bolt hole. From there, I patterned that around with the pattern, what's it called? Pattern on path. So just selected the object, had a sketch that went around. I said put 10 holes equally spaced around it, or 10 objects. So I did that, and then I did a subtract of those objects. Then it gave me 10 equally spaced bolts. Then I cut the body in half, and you can see up here how things were kind of funky there. That would basically either be it would not be connected in that spot. It'd be connected everywhere else, but not up there. So this whole flange would be pointless. But I did notice that, and stop. Waiting. Stop. Are you? So, like I meant to say, I extruded that face in and then combined it. What is that guy? Why did I do that? Oh, that's just because the other side isn't shown. So I combined them. So fixed that. And then this last portion was just a plug part for the top to give me a pressure plate so that I could squeeze the silicone down on top of it with a nice 3D printed portion. So if I go to bodies, it's just a flat plate, but that's my 2 halves of the mold that I printed for the carbon fiber hood. There you go. An hour and a half on the dot. I talked a lot. I showed you guys some things and blew through a lot. Maybe some of that will be helpful. If you have specific questions, just comment on the video after the fact. Maybe it'll help it not do so terribly once it's done. But there you go. Did you have to fill and sand the mold? Nope, just right off the printer. Honestly, I don't find there to be any purpose of filling and sanding the mold, because with this type of molding, in the end, you have to sand the part. Like, you could make it perfect, then you'd probably be fine, but you're going to destroy the mold. So the mold, or you have a high likelihood of destroying the mold. So in the end, just print it and then sand the part when you're done. To me, it's not worth screwing with. I've done so many of these. I've tried to touch up some molds before, and in the end, it's so much easier to work with the carbon than it is and I just print these out of PLA. There's no need for anything else. PLA works just fine. Use a good mold release, and it's just like whoosh. It works great. So easy. And yeah, so that's the whole story, guys. That is everything that I've done to create this stuff. I have no secrets. If you have any questions, let me know. Any specific reason you still use SolidWorks for professional work? Yeah, SolidWorks is a better program for the things that we do in a professional world and how that stuff works. I wouldn't use Fusion 360 for that type of thing. But for being able to have this type of program here at home for the minimal investment I have, or the ability to have it for free, it's such an amazing tool for that. GC Coop 2, thank you, sir. I'm new to Fusion. This show really helps. Thank you. No problem. Aardvark Spleen, thank you as well for the little red rocket. But yeah, you know, SolidWorks is awesome, but damn expensive. 100% agree. There used to be ways to get SolidWorks for like 99 bucks a year, depending if you were in certain clubs, like the AMA. That's one of them. You know, but I believe a lot of those have gone away. For me, Fusion 360 is great for home. The cloud-based stuff is nice. So yeah, how much pressure are you using on the molds? I don't know. It's all by feel. I've used C clamps. I just put some bars on top and I just like crank them down. I'm like, that sounds like it's fine. I'm just, what did my dad always say? Guessing, but God. Like, I don't know. On all fours, RC. Thank you. This answered a lot of questions I didn't know I had. Excellent. I hope it was worth it. I hope that it helps you guys with some of, you go until she moans. You're not wrong. It's about like, oh yeah, you hear something like, oh, that sounded like a little too much. Just back that off a quarter turn. So it's fun. The carbon is fun. All of this process is super fun. And yeah, hopefully this one, I feel like we got through the things we needed to in a reasonable amount of time where you could probably get some stuff out there. I know I don't go through keystrokes the way that I should, but if you have a question with a tool that I was using that I should have been more thorough on, let me know, and we'll try and cover it later. Or I'll answer a comment or a question you guys have on this stuff to the best of my ability. Just comment on the video later if you come back to watch this as a reference. And I should be able to walk you through some of it. But hope you all have a great holiday weekend. Stay safe. Keep all your fingers so you have them for hotkeys. Will you do some 3D printing for a scale garage for Hot Wheels? No scale garages for Hot Wheels for me. Small displays is about all I need there. Thanks to everybody who donated. Much appreciated. Again, come back if you need something. Drop a question. I will do my best. Have a good weekend. We'll see you guys. See you later.